So here I have a Xantrex Freedom HFS2055. It's a 2000 watt pure sine inverter that also includes a 55 amp battery charger for 12 volt systems. I bought this inverter used and I plugged it in. It inverts fine, but the charger functionality doesn't work on it. When you plug it in, the display shows BUL and it doesn't actually charge the battery. If I clamp it, it's still pulling power from the battery as opposed to pushing power into the battery, and the battery just slowly discharges over time. However, when it is plugged in, instead of it pulling power from the battery to do the AC invert, it switches over from the transfer switch. So based on that, I know that the AC transfer relay is good, but something internal to the unit still senses that it's plugged in to tell me that it's in bulk charging mode. However, no power is actually going to whatever battery charger circuit in here exists. So I'm going to open this up and figure out what the problem is. Spoiler, I already know what the problem is because I already had this opened. And it turned out to be a ruptured capacitor as well as a shoddy bridge rectifier. I replaced the capacitors. It still didn't work. So then I opened it back up and I saw one of the bridge rectifier legs were like sheared off. It was really weird. So I temporarily fixed it, and now I'm going to reopen it back up and replace the bridge rectifier now that I got one of those. So I figured I would show this video of how to take this apart and get at the capacitor and bridge rectifier. So let's rip it open. Oh, and I wanted to add one more bit before getting into this. Initially, I tried to get this unit repaired through Xantrex, like inquiring about the warranty on it. And they told me it was out of warranty and it would be better if I went through one of their authorized repair centers. So I contacted 5 of those repair centers, and the 4 that actually wound up replying to me all pretty much said the same thing, that they do not repair these style of automotive units because Xantrex does not supply any schematics or parts for them. That was pretty upsetting to hear, so I wanted to share this fix in case anyone else was experiencing the same failure or just wanted to see what it took to tear one of these units apart for maybe another repair. The first thing you'll see is on the bottom of this unit, there's 4 screws. So we'll take those guys out. Each one of these screws also has a little star washer, so you should take some care not to lose those. So a screw and a star washer. And with that, this lid pops off. It might bind back here, but you'll kind of wiggle it out of the way. What makes this lid kind of tricky is there's a circuit board attached right here that has some wires attached to it. So I'm just going to move these screws off to the side and flip this unit around. So in there you can see the circuit board that's attached up there. We also removed this with screws, so there's 4 screws on each corner of this guy. You can make this a little bit easier to get to if you pull out this cable and this cable. There's nothing really special about these, they just pull straight out of the board. You'll notice that the 2 conductor with the sleeve on it goes to the connector closest to the heatsink. Now we get a little bit more access with this guy. Now we can continue taking out these 4 screws. So now this panel is released. I should also mention that there's a zip tie here that holds on this large like inductor choke on this cord. You can just cut that zip tie off. So we'll take this plastic piece off. I'm just going to put this back. This guy. We'll leave the screws with that too. So before we go too much further, you should either take a picture or a mental note of how this guy is hooked up. So we have this 3-conductor plug that plugs in right here next to the capacitor. We have this 2-conductor plug that plugs in where I mentioned by the heatsink, kind of by this transformer right down there. That's important because there's another 2-conductor plug that goes to this current sense transformer right here that's plugged in here, and you don't want to plug them in backwards because they're the same key. There's also a set of these wires that pulled out when I took the lid off. The white one then there's these wires you can't do anything with. They go into the junction block in here. And then there's 2 wires, a black and a white, that go to these sets of relays. So this white wire comes down on this leftmost relay, and the black wire comes down on the rightmost relay. So we're going to take these 2 screws off to pretty much get this board away. What I'll do with these screws so I don't accidentally use them anywhere else, I'm just going to put them right back into the relay. And with that guy's completely free. So like how on a lot of inverter chassis or things like this where there's a huge piece of extruded aluminum and everything's mounted to, the PCB slides into a tray. So we can remove it if we slide the PCB all the way out in this direction. But in order to do that, what we have to do is there's a bunch of like MOSFETs and other transistor-like devices that are attached to the sides. So what we need to do is we need to remove those screws, which are along the side like this. So there's a set on this side, a set on the back side, and additionally on the back of the unit there are screws here, 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 and here. One other tricky part, there's this red wire that passes through here. To get this guy out of the way, we have to open up the front of the unit to unmount this wire and take it out. So we'll do that. We'll do that first because it'll keep this unit as rigid as possible so we're not like flexing all the transistors and other stuff. So there's one little screw on the side of the unit right there, and this lid comes off. This is the same red wire you see, and it goes into this terminal block. And I said you could take this whole thing apart with just a number 2 screwdriver, but this guy requires a really small flat bladed screwdriver. Let's put that in there. Take that guy out. Let's try to straighten it so we don't rip too many leads off. And we'll put this screw back in so we don't misplace it. Okay, so let's flip this guy back over. Now we can take this red wire and just pull it straight out. There's also a small connector up here that goes up to the front face unit. You can disconnect that from here. That's what we're going to do. And you can see I also took out this 2 conductor from this current transformer. Alright, so now we'll get started taking the screws out of the side of this thing to dismount all the side mounted devices. It should be noted when you take the screws out, the screws hold a small metal plate. So screw, then the metal chassis, then there's a small thermal pad, then there's the device, and the screw continues to a small plate that clamps the device down. So when we take the screw out, you want to try not to lose the thermal pad or the plate. Some of these plates are bonded with a grounding wire back to the PCB, so they actually won't get lost. But what we're going to do here is when we take out any of these screws, I'm just going to lay them out right in front of the unit. So this is the side with the grounding lug. This guy has a little nut on the inside. I'll just hold that with my thumb, and we will get something small to grab the nut. This guy is also a small nut. So take that out, put it on like that. So the layout of these screws is how they came out of the unit in that order. And on the inside, again, we have a dual bank of transistors, another dual bank, another dual bank. Sorry, let me back up. Dual bank of transistors. There's a small temperature probe right here, which uses the screw and the nut. Another dual bank of transistors, another dual bank of transistors. And right here, there's a grounding strap that uses another screw and a nut. And then over here, it's another dual bank transistors. Interestingly, this one on the end, it doesn't have a ground strap, so I can kind of show that a little bit closer now. So on this last one, I'm just going to thread it in so we don't lose it. And we're going to do the same on the other side of the unit. So we're going to put these off to the side in the same order. This guy around. So, quick overview. Again, we have a dual transistor bank right here. We have another dual one here. It's the same method, but the transistors or whatever they are, they're a little bit different. They're like in a thermal sleeve. There's 2 of them. We have another grounding strap that's a little bit different. Then we have the bridge rectifier right here, and we have another set of like transistor packages. These on the left are a little bit different than the rest because they're the same like sandwich construction for the most part, like these dual transistors, but then they have an additional piece of like fiberglass to act as an insulator between the metal and the package. So taking those out. So those 2 thermal sleeved devices, they use a slightly different holding plate, which are these guys. We'll just put their screws back in so we don't misplace them. We'll flip this guy open. So again, another dual bank with the metal bar that's grounded to the PCB. These are the clamps that hold these guys in. The tab faces down towards the circuit board. Same thing with this over here. Then there's this grounding strap right there, which uses this kind of weird shoulder bolt. No idea why it's like that. Then there's the bridge rectifier. The bridge rectifier, take it out, it uses a piece of fiberglass that goes directly on top of the bridge rectifier. And then I can fish it out of there. Just another metal plate. And the same with these guys on the left. Can't really flip them because one's way larger than the other. So that's cool. So what I'll do now is I'll just put these pieces together. They're a lot harder to lose like that. And we'll put these guys off to the side as well in the same order. Okay, so with that, all the devices on the side of the unit are dismounted from the chassis. Yours might be a little... Mine just looks weird because there are holes where there's like standoffs, but mine didn't really have any screws attached to it. And maybe the screws are plastic, so maybe they just sheared off and they fell off in a unit somewhere. But you just might want to look out for those. So there's like a hole there. Yeah, there's a hole over there and a hole at the end right there. So this is almost ready to come out, minus this back plate needs to come off. So we'll do that. The same method. The same method of taking screws out. More. So you can probably forego knocking out these two screws and right next to the So now everything's free and this should pull apart. Give myself a little working room. Untangle these wires a little bit. Well, we gotta dismount this black and white wire as well. Again, just putting the screws back into the relays so they don't get misappropriated anywhere else. So I'm just going to continue pushing from the circuit board, get this guy out. All right, so now our unit is separated. All right, so now I'll show you the parts that I replaced. Take this guy out of the mount. So when I first opened this unit, I found that these capacitors, which are ones right here, one of them was ruptured. Which fell on the ground. So this is kind of what a bad capacitor looks like. The top is bowed out. The whole side of this is distorted, like it heated up significantly. So I knew this was bad. So I removed both of them out of the board, because why not? Because the capacitors I bought came in a 2-pack. So the specs on these capacitors are 560 microfarads at 200 volt. These measured, I want to say 20 millimeters in diameter and 45 millimeters tall. These guys were 40 millimeters tall and also 20 millimeters in diameter. And this is the bridge rectifier. And just spinning this guy around. Take a better look at this bridge rectifier. What was interesting about mine, I can probably superimpose a picture over this, is that this lead right here, it was like cut straight off. So this is a full bridge rectifier, and it converts the AC to DC. So the AC comes in and DC comes out, but with this leg cut off, it got no DC power to the rest of the circuit, and therefore the battery charger didn't work at all. So in the meantime, I just like blobbed solder on the lead to see if that would fix it, and it did. So I know that all I really needed to fix this guy was get a new bridge rectifier. So bridge rectifiers are a pretty common part as long as you match the dimensions on it. So I'll let you get this part number, this GBUE2560. And it's just mostly important that the legs match the same assignment. So you can kind of see here on the board, compared to my bridge rectifier, is negative, AC, AC, and then positive, which this guy's the same thing. And the dimensions are pretty much spot on as well. Which I can give you guys if anybody actually cares. This is just an inch ruler, so you get an idea how wide it is, how tall it is, and roughly its thickness. Cool. Whoops. So what we're going to do here is we're going to desolder this guy out of the board and put this new guy in. So to do that, we'll flip this guy over and we'll get to it. So whenever you handle this board, you always try to want to distribute it to not like flex it too much. There's a lot of weight on it, and there's also a lot of like small surface mount devices on the top, so I'd be afraid of too much board flex. There's this plastic shield right here. You can remove that pretty easy. They're just these plastic standoffs, so if you just pinch them, it'll come out. So when you're removing the capacitors, you just might want to mark what the polarity is. So with the orientation of this board, this smaller trace is negative and this fatter trace is positive. Yeah. You could also figure out which one's the negative trace based on just tracing it back to the bridge rectifier because it is marked on the board. So in order to take these guys out, we're going to need, because these traces are huge and there's a lot of solder on it, you're going to need a soldering gun. I tried it with a 60-watt soldering iron, but that mostly just softened the solder, and I wasn't able to suck any of it out. Much better success with a 300-watt soldering gun. So we'll get that out. So this is the tool that we're going to use. It's a Weller Industrial 300/200 watt gun. D650. And we also have a solder sucker. You'll also need some solder wick because the solder sucker doesn't get everything. So this is just what I'm using. It's off of like, I usually don't deal with power electronics this big, so this is just like out of my small rework bin. So you need something like this, a good solder wick, and finally you're going to need solder to solder the new guy on. So we'll just use, you're probably just going to use whatever you need or have on hand. Cool. So let's get to it. Try to make this a little bit more interesting, Louis Rossmann style, and he would call me a murderer probably after looking at this. So we'll just wait for this guy to heat up. Tin a tip, just make sure it's hot enough. Cool. And we're going to go to town. Just going to go over it again with the solder sucker, trying to get as much as the bulk solder off as we can. So that'll make it a lot easier to work with the wick. And we're going to want to try to keep the same height as a bridge rectifier out of the PCB. So what that roughly looks like, at least on this guy, focus, is you see where there's a shoulder on the device? We're going to go twice that height is how far we're going to stick this guy out of the PCB. And it's slotted, so it should help us. Shouldn't be too critical of like how high and low this is, as long as like we get it within 1/8 of an inch or so. So I trimmed my solder wick. Let's heat this back up. Trimming the wick a little bit so it's easier to manage as it fills up with solder. You could obviously do this however you want to. I'm sure there's a million tutorials on YouTube that does it better than me. But essentially I just heat it up and I pulled the wick out from underneath it to expose the new braid and just continue to wick up solder. All the solder, I hope it's focused, pretty much all the solder is off this guy, and we should be able to start to wiggle this out a little bit. Looks like just these last two joints are causing a little bit of grief, so I'll just try to heat it up. and finally is out. So now we can actually see the real part number of this guy. GBU 1006. Taking it out's the hard part. I'm just going to try to clean up some of this poop that's left behind. Not sure what from. Probably just a bunch of burnt off flux. And we're going to set the new bridge rectifier in. So a quick mental check. Pretty much spot on. They're the same size. Alright, so we'll match the same orientation. Angle tab is at the bottom right. This angle tab's at the bottom right. And we can see the markings on the front. Also match exactly. So I don't know when that stopped recording. But anyway, we got the old bridge rectifier out. Got the new one in. I leave a little bit of solder in this hole, and that allows me to kind of like slip that rectifier in to where it doesn't fall out. And then if I really need to move it, I can just heat up the leg to drag it up or down. And then we kind of set the height, right? So I said it was twice the shoulder height. We can kind of put the old bridge rectifier in its place and see it's pretty much exactly where it landed. So what we're going to do now is we're just going to pretty much flood the rest of these with solder. And then this guy's done. Check the height, make sure nothing moved. Keep at it. Just trying to alternate legs. At this point the bridge rectifier is really hot, so we can just solder right into it. So we place the bridge rectifier, and the last bit to do is just to trim off these excess leads. So just give it, just want to give it like 30 seconds or so to cool down. Put your safety squints on. I guess these don't want to get too violent. They're not flying off into the abyss in the garage somewhere. So that's great. Bridge rectifier is done. So now we can reassemble this guy. So like everything else, we're just going to reverse the steps. So this guy needs to go down, so we'll use the little plastic nylon bits. Just stick it back in. So that secures that. That's cool. I'm just gonna take away my soldering equipment, so it's all away. We'll find out where that pad came from. And yeah. So these were, just to recap, these were the bad culprits of why my charger wasn't working. Faulty capacitor and nuked bridge rectifier. Slide this casing back together. said, we'll slide this casing back together. What I want to do first is just put a screw in the back of this guy to keep the back from flexing. Okay. Oh, well, that's why the screw didn't want to go in, because there's already a screw in that hole. It's a metaphor for something right there. So I just want those screws in because there's these little tiny capacitors that are pretty much one of the only things holding this to these lugs. So I just don't want to flex those too much where they break off. So at least one screw in. Yeah, there's a lot to take out. Alright, so we should start by reassembling all the side components as opposed to locking anything else down, because we want to be able to center the board with the holes, right? Because this needs to either move a little bit left, a little bit right. Doesn't really have that much play. So the first thing I'm going to do is I'm just going to put all my pieces back in order. So this is the bridge rectifier side of the unit. It doesn't have the ground lug, right? So these fiberglass pieces go like that. There's this large grounding screw. There's the thermal sleeve thingies. And then there's just a normal screw on the end. And just taking a peek inside. Yep, that's exactly what we got. So I'll start by putting this big shoulder screw in. And this is one of the least flexible pieces. So if we line this guy up, you can be pretty confident that everything else is in the right location. Alright, so that guy's mounted, so let's work from left to right. We'll start by making sure the thermal pad in here. Try to zoom that guy in. And my camera flashlight won't turn on anymore, so that's kind of annoying. So you can see there's the thermal pad right there lined up with the screw hole. So that should keep it pretty straightforward to just slip the screw in. And then once the screw's in, fiberglass and then the metal. the wings face away and the dimples that stick out face towards the chassis. Let's move the camera. Some things come apart a lot easier than you reassemble them. So we just kind of want to hold these so they don't spin and go crazy. And that's it. So, screw, thermal pad, transistors, fiberglass, metal. Same for the bridge rectifier right next to it. So this is kind of interesting. This might be why the original bridge rectifier failed. It's just so stiff to the chassis, it doesn't really have any flex. So we're just going to be careful locking this guy down, not to go too crazy on it. Hopefully we don't crack it. Okay, now onto these sleeved guys. Let's try to get that wire out. The mounting tab faces the bottom. Just goes between them. Okay, so the camera filled up, so I had to restart it. So this should be right where we left off. And the last thing we got here is to mount this little guy back. So again, we have the thermal pad there, which is good. We'll just take the screw, line this up. So this side's done. I can flip this unit around. Okay, so I mentioned we had a few pads that escaped. So we're going to put these back where they belong. There seems to be a hint of some sort of thermal paste, which has the suspicious outline of the transistors, so we're just going to put those so they are facing the transistors again. And we'll line them up with the hole. So I'll move all my screws back. So we have bare screw, screw with nut, because of this little thermistor guy. Bare screw, bare screw. Then we have this ground strap right here. This is another screw with a nut. And we have one of these loose plates. You want to avoid that, you just want the screw to go through the pad, not to distort the pad. Cool, so all the components on the sides are mounted to the heatsink. So we know that this circuit board can't go anywhere now. We should now mount the rear of the unit. So on the back there's 6 total screws of 2 types. There's machine screws, which go in this hole and this hole, and then there's like 4 sheet metal screws which go in the hole right here, right there, here, down here, and the other one right by the terminal. Okay, so now we will take this red wire, reposition the tripod. So we'll take this red wire here, we'll straighten out the strands a little bit. Not on top of the inverter, so in case anything breaks off, we're not just making short circuits all over the place. And we'll thread it through this hole in the front. But it looks like it wants to focus on my arm instead. I guess that makes sense because it's huge and fat. Okay, now that we got that, we might as well plug these cables back in. So the current sense transformer right here plugs right here. This guy plugs in down here. And we'll reattach the AC outlet. Imagine if I didn't drop the screws, I'd look so much cooler. So the white goes on the leftmost one right here. And the black goes in this middle top position. This is similar. You can kind of tell because the blacks go to the same relay. And then the whites also go to the same relay. So I'll take this screw out. And earlier I mentioned that these lines go. Let's try to readjust this. So if you look real carefully in here, you'll see there's actually text which one goes where. This red wire is always in the way, isn't it? You can see the top one marks an L at the end, and the one on the bottom marks an N at the end. So line and neutral. So line is black, which is hot at the top, and neutral is white, which is at the bottom. So that's where we'll stick this guy in. Come on, fast-ons aren't supposed to be this hard. And again, this board from the top, this cable goes by the capacitor, and this cable goes by the transformer right there. We'll save plugging those in until we get it mounted. And just doing a quick visual where everything is right now. Let's take this off of the mobile tripod. Let's go back on the big tripod. So let's flip this guy upside down. We'll reattach that red wire. Take a little bit more than we need so we can bend it a little bit. And we just want to stick it back in its hole without getting too many strands going in the middle of nowhere. I have no idea why this is like a 10 gauge wire going to the front of the unit for this little signal up here. There's a 20 amp fuse on it from the back of the unit, which is kind of interesting. It's like it's a provision for something, but I don't know what for. Okay, so we mounted that, and I just tugged it with a screwdriver a little bit to make sure it won't fall off. So this guy's done. You can loosen the screw and put this cover back on. Alright, so now all we got left is the plate we took off in the beginning. So the easiest way is to line this up just like how we took it off. I do find this probably the trickiest part of reassembling this guy because wires are kind of short. And some of them even like to get in the way, like this white one. So make sure it's out of the way. Put this back in. And the last one. Okay, now we got have that mounted so we can start closing this guy up. There was a zip tie holding this red wire to that choke, so I'm just going to quickly throw one on it. I suspect they did that just to keep the red wire away from the bridge rectifier. And then we will take this guy, the 3 conductor, plug it in by the capacitor. And the 2 conductor guy gets plugged in by the transformer right here. Ask yourself the question, do you always have a hard time doing some things, or only when the camera's on? And then we'll cut off part of the zip tie we have on the lid. And I'll hope to reuse what's already there. So we'll slip this guy through this choke. Or maybe not. Come on, little zip tie. You're making me look bad. Well, I guess I'm the only one that makes myself look bad. I'll just keep that guy from bouncing all over the place. Make sure we're not pinching everything. One little final check that all the wires are plugged in. Those fast-ons didn't pop off. Apparently it took more than 6 minutes. And I ran out of memory space again. Alright, that is it. This guy is reassembled with no extra screws laying outside, which is a pleasant surprise. So we're now going to take this off the bench, hook it up to a power supply. Okay, we got the inverter hooked up to a set of jumper cables, which is just going off to an AGM battery off in the distance. And we attached a clamp meter to one of the leads, and then I just have this AC inlet here, and then these cords are just things that are attached to it. So this is the output of the inverter, this is the input to the inverter. So I already turned the inverter on, and we can see that we see the battery voltage here, which is groovy. What we'll do now is we will take something like a soldering iron. Move this guy back a little bit. We're going to plug the soldering iron into the front of the unit. We will turn this clamp meter on. We can see at idle we're pulling 1.6 amps from the battery. And if we click this guy on, we should see the power jump up. Oh, meter's on hold. That doesn't help. So if I click this guy on, we see current jump up. So we're pulling 24 amps out of the battery. And this indication shows you because there's a little negative sign right there. If I let go of this guy, current stops flowing. Cool. So what we'll do now is we will test the shore power function of this Xantrex. So again, we have, this is from the wall, this is to the inverter. I guess I'll show you the panel up front. So unit beeps. It says BUL. You hear the relay click. If we look here, we heard the fans ramp up in the unit. And we see we're moving 26 amps and we don't see the little negative symbol, so that means it's flowing in the opposite direction. So right now we are indeed charging the battery, which is great. We'll also see, if we look at this guy, and if we turn on this gun again, the soldering gun turns on. However, we don't draw any additional current from the battery because the AC transfer system working. So this unit, the charger function didn't work, but the AC transfer function worked, as well as the inverting function worked. After taking it apart, found that there's a bad capacitor, a bad ridge rectifier. We replaced those components, reassembled it, and we find that the charger's working great, the inverter works, and the transfer switch still continues to work. So that concludes this questionable repair video on this HFS2055 Xantrex sine wave inverter. Thanks.